So today's session is about the Azure AI fundamentals, specifically about the computer vision. We'll be going through several stuff today, but by the end of this session, you will be able to know. Um, you will be learning the following during this session, which is the computer vision concept. What is computer vision? Applications of computer vision, and the other part would be on the computer vision in Azure. We'll be looking into the conjunctive services, image analysis, training models, analysis, analyzing faces with the face service, reading text with the computer vision service, and finally analyzing form with the form recognizer services. Starting with Azure concept, um, so there is different several parts in here explaining what is or several components, if I'd say, in this area in terms of computer vision. First one I'll talk about is the computers. Okay, so or the sites where what the components that's being used to get the data and analyze and do all the other techniques in there. So computers can see the world through the digital images, such as photographs, live cameras feeds, or recorded video files. Okay. Each digital image is actually an array of numeric values inducting the color intensity of each pixels in that image. You can use these values just like any other data as features to train the machine learning model. To apply transformations to and calculations to learning models to analyze the image data and patterns in it. Okay. Uh, in the case of color images, there are these layers of pixels values for red, green, and blue intensities, as you can see in here. Okay, so I have three different parts in here. I have the red one, the blue one, and the green one. Every pixel in this image will be divided into the image will be divided into different pixels, and that's why how you start doing like the training the models based on that. I think last week I've showed you some examples from my own work regarding that, how basically divide the image will be divided into multiple images, and it will be split into multiple images or parts in there in order to do the analysis on that one. Okay, so what are the applications of computer visions? Well, we have so many applications existed already, and maybe some of you have experienced some of them before or have read about them before. So the first one is we have the image classification. An image classification model uses the numeric pixels features to predict a class label for the image. For example, in a traffic monitoring solution, you might use an image classification model to classify image based on the type of vehicle they contain, like taxis, buses, cycles, bicycles, vans, things like that. So essentially, image classification model answer the question to what is in the image, what is this an image of? Okay. The second one we have is object detection. So for object detection, basically, model, they are trained, the models are trained to classify individual objects in the image and to indicate their location within the image as bounding box, okay? Like how you see in here, this box, basically. So, for example, you could extend the traffic monitoring solution to detect the presence of multiple classes of vehicle in an image. Object detection models are used to answer the question like what objects are in the image and where are they? Okay, so you can see here. So in terms of objects, this is just an example. For example, it shows that this is a bus, this is a bus, this is a car, cyclist, and so on. So you can detect more than that in one image, basically, like a tree, a traffic light, so on. So, but these based on what we want the model to do. The third application that we have is semantic segmentation model. It's an advanced kind of model that classify individual pixels in the image based on which they belong to. For example, the traffic monitoring solution might use a semantic segmentation model to overlay masks on the image to indicate pixels that are belong to buses, cycles, cars with different colors. Okay, and so segmentation, semantic segmentation answers the question which pixels belong to which object. Okay. So like you see here, for example, this green color, you see it cycles. The red one for the buses, the blue one for the car, and so on. The fourth application that we have in there is the image analysis. So you can build an object detection and classification model to perform image analysis, generate caption and tags based on the image, on what the image contains. Okay. So like you see here, for example, a person with a dog on street. So it detects that there is a street, there is a person, dog, and that person is with his dog, and so it creates a caption for you in there. The fifth one, which I think most of you have heard of, is the image face detection and recognition. Okay, or face recognition, basically. Face detection is used to identify the location of a human face in an image. Further analysis can be performed on facial feature to determine the facial features, emotions, age, and so on. And the model can be trained to identify specific individuals based on the facial recognitions. So some of you might heard of the system that's being used, like this kind of system is basically can be used in the airports to detect like criminals, to if the government, for example, or the police looking for a specific person, so they can run the person's image through the model, and based on the captured image in certain areas can be detected if that person is there or not, and so on. One of the things also that's face detection or face recognition used is on one of the social media platforms like Instagram, I believe. So basically in there, what you can see, so you can choose a kind of filter and it tells you how sad you are or how happy you are. I know some of you might have experienced that. Yeah, So, and the last application that we have today is the optical character recognition. So an OCR, which is a shortcut of the optical character recognition model. So that model is to identify regions of the image that contain text and extract them. Okay, like how you see in here now. So you can basically take that picture and detect, for example, the text in that picture is like how now, I think this is now recently started to be used in iPhones through Apple iOS softwares. So I can basically, let me try. So I can basically just take an image, a picture from my phone. Okay, go to the images there. I can literally select yeah, I'm just testing it now. I can select what is the picture contained in there. I can copy that text and go and send it to you now. Should I send it? No. Okay. So these are the applications that we have now. So shall we, let's see how these applications actually work if I have an image, okay? So let me run a demo for you. Can you all see my screen? Just to make sure that everyone sees my screen. Yes, okay, good. Yeah. Because I see you guys very silent today. Very quiet. You have the mic. So yeah, so for example, the analyze and describe image. So I have sets of images in here. Okay, so what I need to get a description of this one, for example. Okay, so it tells me in there a city skyline with water. Okay, the confidence of the model is 27%. Okay, it tells me if it's other content or racy content. So it tells me it's false, so not. But it has water, 100%. It has a sky, 100%. A lake, 95. Outdoor skyscraper, overlooking day, reflection, and so on. So it describes to me with tags on what this image is. Okay, let's take another example. This one, for example. So you see this guy, this one, without looking into this, you see like buildings, cars, street, road, traffic lights, and so on. So let's look at the tags. It is outdoor, skyscraper, buildings, road, car, downtown, city, vehicle, sky, street, way, city escape, um, busy, highway. So it gives me like the highway, for example, is 14%. So it's not really sure. The model is not really sure. It's not really sure about if this is correct what he that, but he provides you with outdoor 100%. You can make sure that, oh, it is outdoor. It is a road by 96%. There are buildings. It's a city. It's downtown. There's cars, vehicles, and so on. You see these stuff in here are like very high percentage of confidence in there. But you see, for example, these two, not really. You have 30%, 14%, and then you get a description: a street with cars and buildings. So all of these stuff actually being generated by the machine learning or by the model that's being used. Okay, and let's take last example. So this one, from this picture, even though it's blurry and stuff, but because it divided into pixels, so the model start to understand the picture, to learn the picture more. Okay, so it tells you 100% road, 100% outdoor, 100% car, buildings, vehicles, land vehicles, and so on. Okay, so a yellow car on the street. Imagine if you were to describe it, that how you would be describing it. For example, as a human being, I would go, oh, this is a taxi on the road, okay, a taxi on the road. You can get more, of course, explanation description for that, but like the confidence of the model is 55%, even though it is correct. Okay, but the reason that might be quite low, like 55%, is because there is some other descriptions that can be added in there. Okay, so road text in imagery. Okay, let's say if I have signs, for example, like these signs on the street, most of us can see it. Most of us, we see these signs on the streets, on the roads, right, driving or walking. So you see, like here, these signs in there. So it gives you a transcript of what is actually written in there. Okay, so let's say this one. So it's from this one, the only readable one is actually taxi, the one that's you see it on the top of the taxi here. So it should it generate this transcript for you in there. And the read handwriting imagery. So let's say you have something like this, it actually it transcript that for you. Okay, something like this, for example, out of order. Sorry for any. Actually, reading it from here is much easier than reading it from there. Sorry for any inconvenience caused. So see, that's these things you can do it basically with the these kind of with the computer vision applications. The last one is you can take a picture, okay, and it tells you what that building, if it is a famous building, if it is a celebrity, a picture of that bridge, of a bridge, for example. So it tells you like, oh, this is the White House, and my confidence is 99%. Okay, like if you want to take one of the celebrity, for example, this is that person 100%. Okay, the Statue of Liberty, for example, and all these things. So all these stuff, it gives you, you can basically predict or get out of the computer vision applications. Okay, it's quite interesting actually. Do you have any questions so far? How are you finding these kind of things, guys?
It's interesting, no doubt.
It's interesting, but at the same time, I think it's the concept of understanding everything is taking time to process in our brains.
Mhm.
Because it's just
Yeah, yeah.
one of those things. You know it, but when you're going in the depth, like how it's done, we know, okay, this is AI. It's easier to say, but when you're sitting down to study it, it's just harder. Do you know what I mean?
Well,
Sorry.
I think we already have some labs. Okay, I don't know if I sent you the link for the AI 900. I did it, fortunately. Uh, Let me send it in the chat in here. So that's the GitHub in there. So what you have in there, it's just some like you do classification modules. Okay, so you do for the classification. So you tell the application will tell you this is a banana, this is apple, this is orange, and so on. You already giving you all these kind of codes. So what it does, the way that it works, okay. Uh, let's say if I want the to do the okay, let's say I want to do something, an algorithm to read the signs on the roads. Okay, so most new cars as well, you might notice it. Most new cars, okay, they have AI algorithms or computer vision application where it reads the speed of the road, okay, and it shows you on the dashboard while you're driving the road speed is 70 or 50 or 40 or 20. And it's I wouldn't say it's 100% accurate because sometimes you will find like two roads alongside each other, so next to each other, and one of them is 20, the other one is 30. So it might get confused, but the accuracy, okay, which I myself faced that or recognized that, seen that, is over 95%. Over 95% of the time, my car shows me the actual speed road. Okay, some of the cars, the new cars, uh, some of the cars like the new S Class, the new Mercedes S Class, for example, it shows you some signs on the road. Okay, uh, light signs. So it shows you some signs on the roads that basically it detect it detect the how to say, the sign on the road and display it for you, like how you see here, for example. It sees this one and it's displayed to you a sign here that there is a road work on this road. Okay, so these are kind of things that can be done, but how it's being done, you have to train the model. You have to train your algorithm. You need a set of data or that's pre-collected, okay, and then pass it to your model. So the data, I explained the last time that the data that you have, you split it into testing and into training and testing. Okay, so for example, you have 70% for training and 30% you leave it for testing. So that 70% that you have, okay, you pass it into your model, into the algorithm, and tell the algorithms, look, this is the data that I have, learn from this data. I start training the model based on that one and tells, okay, now it's now you learned, let's test if you learned actually. Like how you actually do, for example, we learn, and then when it comes to the exam, we do the test, we either pass or fail. Okay, so based on our grades, how well we do, we either pass or fail the test, for example. It's the same thing when it comes to the machine learning or AI in general. You have part of your data that needs to be trained, it needs to be used for training, and then you have other parts of the data where you're testing your model. And oh, so okay, now I have 90% accuracy of the model. Okay, this is my algorithms has passed the test. Okay, let's pass it now. Apply this technology on the roads, for example, on the software, on the applications that I have, and then one by one it will start to learn the new things that will be detecting in there, based on what I trained my model. Okay, so if you want to train your model on the tab of cars, for example, on the type of cars that's being passed on the roads, like car, van, lorries, bicycles, or anything like that, you don't pass a data that's not related to that thing, because this algorithm will be working on something that how it's being trained. Okay, I can't go and give a lecture about let's say business when I'm doing computing. It doesn't make sense, right? Because my study is all in computing. Don't take me and put me in a business class and tell me to teach them. I wouldn't know how to teach them. Okay, I'll try, but at the end I will fail teaching them because that's not my area and I don't know anything about that. But if you take that the data that's related to the model based on what you exactly want the algorithm to do for you, it will then become what you expect to. It will do what you expect it to do. Okay. When it comes to applying these kind of things, the deeper you go in there, it might get more complicated. But once you understand the initial idea, the concept of it, it will become easier for you to go further steps. Like, okay, now I understand the concept of computer vision. I want to apply it. Once you apply on like simple, once you apply it on a simple examples, okay, now let's apply it on more complicated one. Until like you want to keep try and try and try till you get your algorithm to do what you exactly wanted to do. So hopefully that was clear on how to do like why we're using computer visions, why we're using these applications, how to use them, and once you start applying uh, the labs, basically, it will become clear to you. Oh, okay, I didn't know that this would be that easy. Or for example, because you will find it easy once you apply it, because it will become because you already understand the concept of it. Yes, Savira, you have a question?
Yes, I have a question that these labs we can apply through the Azure portal, right?
Yes,
And for this we need to wait, right?
we'll fix that today. So today we'll be doing the labs.
Okay, perfect. Thank you.
No, no problem. And the same thing, some of the applications you may see is the translation, for example. Uh, do you think that once we create it like like Google Translator, do you think they pass all the languages, all the words in the world? Like imagine, for example, in English language, how many words in English language? No, number of words. Uh, let's check. I think there will be around, yeah. So it's like 1 million, over 1 million words in English language. Okay. So imagine if you want to that's just for one language. Okay. So imagine if you want to go there, you have all these sets of languages, all these sets of languages. How can you pass like all these? You need to pass all the characters. That's if you want to do it manually. I'm saying you want to pass all these characters, all this stuff, all the words in that languages and their meanings and so on. So if you write anything in here, it will basically tell you the meaning of it and so on. But that's not manually done. Okay, that would be like set of data. I have 1 tera, 2 tera, 3 tera, 5 teras data regarding the translation in different languages. So I pass it to the machine, and the machine starts learning from itself. That's how it works. It doesn't work like, okay, I'll add all the alphabets, I'll add all the words in every language, and then it will do the work. No, that's not how it works. Uh, so that's one of the applications. I'm not necessarily for the computer vision, but in general, for in terms of AI, this is one of the applications that can be happen that's actually exists in ABI in AI, and the other one that's been uh, I'd say the other one is with the keyboard that you're using on your phone. So it you already have some AI algorithms in there where it tells you, oh, do you mean this word? Oh, do you mean that word? This or that? It will correct the spelling for you, and so on. So these all are applications, AI applications that actually exists in our lives at the moment. Is everything clear regarding that? I feel myself. I took the law. Yes, sure. Go ahead.
Hi, Mohammed. Hi, yeah. So I was just wondering, is that the same principle for? Do you know when it uses for security, sort of like two-step security, and it asks you capture images, and it'll say pick out all the boats on this image. Is it following that principle? So the computer has a database with a number of that something will tell it it's a boat or a car or whatever, and it tells you pick out all the cars.
You mean like that Google capture thing, right?
Yeah. Do you know when it's like verify you're not a robot?
Yeah.
Yeah.
So yeah, basically, yes. This is one of the things that's being used in there. Other one is sometimes it's used like when it comes to security as well. It's something to do with your emails as well. So you see, like some of your emails goes to the spam or junk file, the junk folder. So the reason for that, because there is an algorithms that's already Google using or Microsoft using to sort out their emails. So there is different requirements, of course. So what it does is it scans the email for you before it basically decides whether has to go to the inbox directly or to the spam folder. So,
Okay.
for example, it contains like malicious links, some files, so on. So that's why sometimes you see that it's not 100% accurate. Again, there's
Yeah.
nothing such a 100% accuracy. There's always a space for an error in there. It could be like, I'm not saying as well it's very low accuracy. So like it could be like 2%, 3%, or even 5% of an error in there.
Yeah, got you.
So that's why it scans the email and then classify it whether it is a spam email or a normal email. There's nothing danger there. So
Yeah.
these one of the stuff that we actually face it in our day every day. Another thing that you have on your phone. So if you drive and you connect your phone every day, if you go every day at 9 o'clock, okay, to your work, for example, you drive to your work and you connect your phone through Bluetooth or cable, Google Drive or anything, Apple Drive and so on. So what it does, the existing model on your phone, one of the models, okay. For example, if I'm at the university and it is 4:30, once I get into my car and connect it, it will instantly tell me that, oh, you need 20 minutes to get home.
Okay,
Literally, I get notification onto my phone and say like, oh, you need 20 minutes to get home now. Literally, that's what it does to me every time. I mean, that I'm facing that every single day.
Yeah, got you.
Because it learns from my behavior that by this time I actually go home. Okay, when I connect in the morning, it tells me depends on the day as well. Like for example, I go to the university on Mondays and Tuesdays to my office there, and like once I connect to my phone, to my car, it will recognize that I actually connected to my car first, and then it tells me to Birmingham City University you need 12 minutes. Sorry, 12 minutes, for example. So these one of the applications that we use, but we don't recognize how it's being done or what these kind of application, how these things are actually working. I don't think we thought about it in depth as because we didn't we didn't understand the concept, I believe. So, but once you understand the concept of what exactly is happening, you say, oh, this is something I do every day. This is something that's happening to me every day, every now and then. So you start to recognize, oh, this is something that actually exists in our life. Even though it might not be useful for you to know that you would take 20 minutes to get home or like 10 minutes to get to the university, for example, but still the algorithm, somehow it's working. Yeah. Do you have, guys, any questions? Can you relate to any example in your life, for example?
Sorry, it's Ali.
Yeah,
You know the example you just gave that when you connect your phone to the car and it gives you after, let's say after 3 days, they start telling you it's 20 minutes to university. So is that the connection training the model, machine learning model, or is it something is picking up regularly or something already in there that picks up that behavior?
Okay, so basically, I do understand how, you mean the mechanism of the algorithm, how it works.
Yeah, how it works.
Okay, so basically, once you connect your car through Bluetooth, let's say, for example.
Yeah.
So every device, every electronic device we have, it has they have a unique MAC address. Okay. So that address is unique for every single device in our life. So the laptop has one MAC address, the screen, the mobile phone, the car. So every device we use, it has a unique MAC address. Yes. So once you connect, it's recognized that this ID is actually a car. Okay. That's first. And then it will understand, like, you will start using it for a week, for example, and then we start learning. Oh, on Monday, this person goes to the university at 9 a.m. and come back at 5. Okay, it will start monitoring your behavior, and will start understanding or learning what you actually do. Based on that, start to give you suggestions. Okay.
Oh, okay.
So it will
Okay.
start learning from you. It doesn't learn by itself. It learns from you. So based on your behavior, that's how it actually starts to learn. And that's why data is very, very important. So everything we do in our life is surrounded by data. Every single thing, any decision, anything. If you want to make a decision on opening a business, on buying a car, you look into reviews and all these things, right? So if you want to buy a car, you look into reviews, what this car has a feature. So these kind of things are data. That's based on this. Oh, this car has this, that car doesn't have. Okay, I'll buy this car, because you are based on that data that you or the information that you got. You made your decision to buy this car, for example. Okay, and the same thing if you want to move to a new neighborhood. Okay, you look. Oh, is there any schools around? Is there any shops around? Is it safe in this area? Is it? You start asking yourself questions, and then you make your decisions. So our lives in general, if you look into it, it's all based on data. It's all based on what to like. So our decisions based on the data that we are surrounded by.
Yeah.
So, and that's why data is very important. I mean, like in the USA elections for the president, when Trump got elected, you all, I think most of you heard about the Cambridge scam thing.
Yeah.
So it changed the whole election for like it changed the whole election results.
Yeah.
Just based on that, and Facebook got sued, Google got sued for that.
Yeah.
So imagine what data can do. So it's in the marketing, you can use the data in marketing to show like, so basically you can control people's feeling through the market, through the social media as well. This is like very dangerous stuff. And that's why like social media is not made for everyone. That's my opinion. It's not made for everyone. So like if you actually don't know what you're doing in there, or why you're using the social media, it's better not to use it, because it will control you at some point. Okay, like if you have kids and stuff, is all the time on social media. You see all those kids on social media all the time. You see, like the whole generation has changed.
Yeah,
the whole generation has changed because of the social media. Because sometimes you look into one thing, and then on the internet, for example, and you go to Facebook or any other platform, or Twitter or anything. Okay, you start on. After I was just searching about this. It looks into what you actually search, and then shows you something related to what you want to do and stuff. So it plays like it understands how people behave on the internet and show them something that related to them. So if you are, let's say, very happy and like you're having a great day, and you started listening on YouTube to some like very happy songs and stuff, all the suggestion that you could see there is actually happy songs. You won't be seeing like something that's not related to the mood that you are in. So all these stuff, and I think after this session, all of you will start actually realizing these things. You start like saying, oh, actually, I'm having these things in my day every single time. So that's these the things that what we can do with the AI in general. It actually exists, but I don't think we actually realize that, because we didn't have an idea on the concept of it. Okay, so carrying on, the computer vision in Azure. So and hold on, I'll mix up with the slides. So Azure provide a set of conjunctive services that's encapsulate common AI workloads, including computer vision tasks. So you should build your own computer vision model using machine learning, but it is a complex area, as we were discussing. So using of the shelf services can help to develop a solution more quickly and with less specialist expertise. To use a cognitive services, you must provide a resource in your Azure subscription. So this can be a standalone. This can be a standalone services specified service specific resource. For example, a computer vision resource, okay, or a general cognitive services resource that uh, encapsulate uh, multiple services. So using a standalone specific service specific resource enable you to manage costs and access to that service independently of other services you may be using. While a while a general uh, conjunctive cognitive services resource enables you to combine all your AI services in a single Azure resource for centralized management. Regardless of the type of resource you use, a client application will consume the services it provides by connecting to a REST endpoint, which is an HTTPS address to which they can submit requests using a resource specified for a specific key for authentication. Okay, so in this course, you will be using Python, uh, Python notebook in Azure Machine Learning Workspace to run simple client application. So you're not expected to be experienced in the experienced developers or data scientists. So Python code and notebooks may be new to you, but resources we have all the resources for you. Okay. And the Python code that you will be used in the lab is provided to you already. So the key point is to see some of the concepts in action, okay, and to learn how to develop the software or the algorithm. So the computer vision the computer vision cognitive services provide a pre-trained computer vision model that you can use to analyze images. So the service is powered by demonstration demonstration in the previous lesson. So the model can detect and locate over 10,000 classes of common objects. Okay, generate an automatic caption for the image and set relevant tags that relates to its content. Tags can be useful if you need to index images and search for them using relevant keywords. Also to detect and analyze human faces, enable content moderation by identifying images that contains adult, racy, or gory content. Detect and extract text in an image. We'll be exploring this in more depth later in this module. So in Azure Learning Workspace, you will need to use the Azure with a computer vision, one that I provided in there somewhere. And Azure analysis with computer vision. This one. So this is the one I'm talking about. Okay. So you'll be doing all these stuff in there. Yep. So back to this. The customer vision congestive services enable you to train a custom model for either image classification or object detection. Okay, we talked about classification in general in the last session. Anyway, the service provides a web-based portal in which you upload your own image, label the image or the objects in them, and train and deploy a model. Okay, so you can then consume the model from client application using its model model ID with the endpoint and key for the resource in which you deploy it. Okay, so you see here object detection is different than the image classification. Image classify this is apple, this is banana, this is orange. So here it detect, oh, this is banana. It shows you that. It gives you a box. Put it in box here. It shows you this is banana, this is orange, this is an apple, and so on. Analyzing faces with the face services. So while the computer vision services provide some basic face detection and analysis feature, for face services offers additional capabilities, including analysis of facial attributes and ability to compare faces for similarity, or even to train a facial recognition model to verify identities or individuals. Okay, so one of the verification models that already exist as well, that's used by the post office, or the if you want to do DBS check and they want to verify your identity, it will take you to another application that's provided by the post office, just application on your phone where you scan, you basically take a picture of your ID, the front one, in the front and then the back, and then you take a picture of yourself and then compare them. Is this actual person or not? And then it's verified. It tells you either the verification pass or verification failed. This is one of the things. And also, this is one of the modules that I was telling you about, is like the happiness, for example, of the person based on some elements or like some expressions, if I'd say, that's being taken on the picture, okay, from a picture. We've already discussed computer vision services and its use in image analysis. So it also provides OCR capabilities to detect and extract text from images. So the services provide multiple applications program interface, APIs. That's the shortcut of it. So application programming interface, the shortcut of it is API. If you have ever wondered what API stands for. So that software developers can use to extract both printed and handwritten text from images. So from immediate reading of small amount of text in images and synchronized text extraction from large documents. Okay, all of these labs is already in here. So you have face analysis, object detection, OCR, optical character recognition. So you have all these stuff, all of them one by one in here. And last but not least, the form recognized services offers more than just detecting and extracting text. It enables you to use models that understand the form fields. For example, identifying specific type of data such as like address, phone number, date, time, quantities, and understanding the relationship between fields, labels, and values. So you can use form recognizer to train your own custom uh, form form extraction model based on your own scanned forms, or you can use the pre-trained receipt model to extract information from scanned receipts. So that would be it for these materials. How was the computer vision in general? Do you guys understand it?
I'm sorry,
Yeah,
I have one
interesting.
question. Could you be a little bit back on the slide, please?
Yeah.
Okay, what is the meaning of pre-trained recipe model? What does that mean?
Okay. Pre-trained is a model that's been already trained for you.
Okay.
That's what pre-trained is.
Okay.
So a model that exists already pre-trained
Okay. Yeah.
for a specific thing, and you can just use it without training,
So
or
they
you
are
can
also
train the model again, or use it just for testing, or just use the model directly.
Okay. So there could be a model which are without testing and without training.
Without you can use it without training.
Okay.
You need to test it to make sure that it's working
It's working.
as
Okay.
you expect.
Okay. Okay.
All right. I was hearing another voice. Anyone has a question? To be honest, I enjoy this computer vision a lot. This is one of my favorite part of AI. Do you guys have any questions regarding the computer vision? So we covered the following today. Computer vision concept. What is computer vision? We talked about the applications of computer vision in terms of face recognition, object detection, and so on. We talked about the computer vision in Azure, congenitive services, image analysis, training models, analysis, analyzing faces with the face services, reading text from computer vision services, and analyzing forms with the form recognizer services. That's what we covered so far. If you want to read more in depth about this, so you can use this link to explore more in depth, I guess. If you want, I mean, like this is, if you like AI, you will find once you start applying AI stuff and so on, and if you like it, I 100% recommend you to read about this more, applying more, start to get ideas about algorithms, learning about what is actually happening in there, in that area. Just today, I was reading about the Meta, which is Facebook before, AI supercomputer. So I was reading about this today, and it's one of the largest and fastest supercomputer for the AI. So, and I think why they're doing this is because of the technologies that they will introduce very soon. That's why the AR technology. So the AR technology is very important, and it's becoming very popular, basically. And also the VR as well, the virtual reality one, which I think in 10 years time we all will be using it. We don't need to go to the office anymore. Just hey, put the VR set on, and you'll find yourself in the office instantly. So, any questions? How do you find? Which one do you like more, the cloud part or the AI part?
Definitely AI.
AI.
AI, definitely.
Yeah, I think AI is more interesting.
It's
than
more
cloud.
relatable.
It is. It is. So AI, you can relate it to many applications in our life, but the cloud is actually where all these things is happening, is stored. So it's something that we don't see, right? If I say it is the backend of what we the applications. So everything is stored in there, is processed in there. So that's what's happening on the cloud. While on the AI, you can relate to many things that in our lives, happening in our life on a daily basis. I think once you get to the data part as well, you will like it as well. Yeah, I'm so happy that you all like the AI one. It's my specialties. Yay! All right, so I'll stop the recording for this one then, because the rest of this will be mostly practical and with just discussions and stuff.